Okay, let's jump into today's deep dives. We're looking at a massive challenge in the AV world.
A really common one.
Right. How do you get a perfect high-res video signal from here to, well, way over there, like over a mile away?
Yeah, your standard copper cables, they just give up. They fail spectacularly long before you get anywhere near that kind of distance.
So we're digging into how DVI-Gear tackles this with their DVI-7312 extender.
Right. It's a single-link DVI fiber optic extender, and the performance it claims is pretty extreme. We're talking DVI signals up to 2 kilometers.
2 kilometers, that's about 1.2 miles. And it's surprisingly, not astronomically priced for what it does.
Exactly. So the basic idea, the secret sauce, is that it swaps electricity for light.
Electrons for photons.
Yep. You have a little transmittal module that turns the DVI signal into light pulses.
And then a receiver on the other end that just turns it right back into DVI.
That's the whole trick. And all you need running between them are 2 tiny strands of fiber optic cable.
Which is nothing compared to lugging thick copper, right? Just these hair-thin strands with LC connectors on the end.
So when we actually look at the specs, the distance numbers are remarkable for a single-link solution. It supports 1080p and PC resolutions up to 1920 by 1200.
But the cable type makes a huge difference. The source says 500 meters with multi-mode fiber.
Standard 50125 multi-mode, yeah.
But then it jumps to the full 2,000 meters, 2 kilometers, if you use 9125 single-mode fiber.
Right.
So why does that tiny difference in the fiber's core size give you, what, a 4-fold increase in range?
It all comes down to signal loss, or really minimizing it. Single-mode fiber has that much smaller core, which basically forces the light to travel in a straighter, cleaner path.
Less dispersion.
Exactly, less dispersion. So the signal stays strong, and you can hit that max video bitrate of 1.65 gigabits per second over that really, really long distance.
And of course, the big reason you're using fiber in the first place isn't just distance, it's about signal purity.
Oh, absolutely. The source is very clear on this. Optical transmission is completely immune to environmental noise, RFI, EMI. None of it matters.
That's the whole game right there.
It is. And to be as efficient as possible, they're using something called WDM wavelength division multiplexing.
Okay, so what is that doing?
Essentially, they're using 2 different colors of light at 1310 and 1550 nanometer wavelengths to send and receive data at the same time over those 2 fibers. It just maximizes the throughput.
That's pretty clever. And that leads to another really smart feature they mentioned, something that installers would love. The programmable ED'd Emery chip.
Yes. This solves a huge headache.
So why is that ED'd support so critical here?
Well, DVI needs this handshake between the source and the display, right? The display data channel, or DDC. And for years, that meant you had to run little copper wires alongside the fiber just for that handshake.
Which kind of defeats the purpose of being purely optical.
It does. And those copper runs can fail. By baking the EDID memory into the transmitter, the source always thinks it's connected directly to the perfect display. No need for the extra copper. It's a pure optical link.
Okay, so performance is amazing. The engineering is smart. Let's pivot to the constraints. Because for anyone really analyzing this, there are a couple of huge catches.
Big ones, yeah. And this is the critical part. First, the specs explicitly say HDCP communications are not supported.
Not supported at all.
And second, digital audio support is listed as none. So this is a pure long-haul video-only solution.
The lack of HDCP is massive. That's the content protection, right?
That's the one.
So if you plug this into a Blu-ray player or a Roku, you're going to get a blank screen.
You'll get nothing, which tells you right away this is not for consumer media, not even for most commercial media setups.
Exactly. It's not a convenience product. You're trading those consumer-grade features for supreme signal integrity and that extreme distance.
It defines a very specific high-performance niche. It's TAA compliant, it's built for reliability with a 3-year warranty. Even the power draw is super low.
So let's wrap this up. We've analyzed a device that throws out common AV features, like audio and content protection, to do one thing perfectly.
Right. It achieves flawless video over a mile away using light, with 0 chance of electromagnetic interference.
Which leaves us with a final thought for you to think about. Given this extreme range and signal stability, but the very deliberate lack of HDCP, what kinds of professional or secure applications think medical imaging or maybe industrial monitoring or even defense visualization would actually prioritize this exact setup, where the absence of media protection might even be a required feature?